So this set of videos is on Chapter 11 Vectors in the textbook and Section 9 in the AS spec and Section 10 in the A-level spec. And this first video is just going to be on vector basics, and it's just going to go through the absolute basics of vectors, which hopefully you already know a little bit about. So basically a vector at its core is just something that goes right or left by a certain amount and up or down by a certain amount. So for example, let's say we have a vector that goes right by 3 and it goes up by 2. The overall vector is going to look like this, like that, and we put an arrow on the end because it's going in this specific direction. Let's do another example where let's say it's going left by 3 and it's going up by 1. The overall vector is going to be like this. There. Let's do one more example. Let's say that it's going down by 4. And let's say that it's not going left or right, therefore the overall vector is just going to be like that. Now, to be honest, you don't actually usually deal with vectors kind of in this way in this course, but I think it's good to know kind of what vectors actually are and how they look. So there are three ways that you can write vectors. The first way is one that you might already be familiar with, which is by a column vector. And this is when we write the vector like this, where A is how much it goes right by, and then B is how much it goes up. So for this first example, we saw that it goes right by 3 and then it goes up by 2. So that's the column vector. Remember that the top number is whether it goes right or left and the bottom number is whether it goes up or down. Now for this second one, it actually goes left by 3, so we give it a -3 because it's going in the opposite direction. It's going in this direction here, and then it goes up by 1. And for this final example, it doesn't go right or left, so it's just 0, and then it goes down by 4, so it's going to be -4 as it's going down, and that's how you write it as a column vector. The second way that you can write vectors is in the I and J form, and you might not have seen this before. Basically, the I and J form is just when you write it as AI plus BJ, where A and B are the exact same as before. A is how much it goes right by, and B is how much it goes up by. And it's very easy to convert between the column vector and the I and J form. So for this example, it goes right by 3, so it's going to be 3I, and it goes up by 2, so it's going to be 2J. And as you can see, it's very easy to convert between the two forms. They're the same thing. The A and B are still the same. For this one, it goes left by 3, so it's going to be -3I, and it's going to be +1J, but 1 we don't really need to write as a coefficient, so we just put J. And then for this example, it doesn't go right or left, so it's 0I, so we don't need to write the I, and then it's -4J. And as you can see, it's so easy to convert between the column and the I and J form. They could also ask you to calculate the magnitude of a vector, and this is basically just the length of the vector. It's basically just the length of this line here, and this is really easy to figure out because we have a right angled triangle here and we have these two lengths here, so we can just use Pythagoras. So let's say we have a vector A, and A is equal to x, y in column form. The magnitude of the vector, and whenever we use magnitude, we use this symbol here where we kind of put these two straight lines around A. The magnitude of A is just equal to the square root of x squared plus y squared, where x and y are the column vector here. So for this first example, for vector A, the magnitude of vector A, again when we use this symbol with the two straight lines around, is equal to, and we have the vector here, or we could have it in the I plus J form here, equal to the square root of 3 squared plus 2 squared, which we put into a calculator, which is equal to the square root of 13. Another example for vector B here, the magnitude of vector B, again we just put these straight lines around the vector, is equal to the square root of -3 squared plus 1 squared, and if you put that into a calculator, that's just equal to the square root of 10, And then for this final example, vector c, the magnitude of vector c is just equal to the square root of 0 squared plus minus 4 squared, which if you put into a calculator is just equal to 4. And that's how you find the magnitude. So another thing you might need to find out about a vector is the direction of the vector, and this is something that you need to actually figure out. You can't just figure it out just by looking at the the 3i plus 2j. So for this vector, it wants you to find the angle between the vector and then we'll either say the x-axis or I, because remember it's I plus j, or it could be the y-axis slash j. And in this example, it's given the x-axis. And I want you to find the angle between the vector and the x-axis. And what it's actually asking is it wants you to find the angle between the x-axis here and the vector here. So it wants you to find this angle here, which we're going to call theta. It wants you to find this angle here. And we can do this because remember, this is a right angled triangle. So what we can do is we can do the kind of right angled triangle property. So this is the angle we're trying to find. So this is the opposite. This is the longest side, so it's the hypotenuse. And this here is the adjacent. We know O and A, so therefore we don't need to know anything about H. So therefore, if you remember SOHCAHTOA, we can use tan theta is equal to O over A. And then we can just plug in the values. So tan theta, because we don't know theta, is equal to O, which is 2, over A, which is 3. Remember, we know this because the vector is 3i plus 2j, and we know what it goes in the x and the y direction. So therefore, theta is equal to the inverse tan of 2 over 3. And if you put that into your calculator once it's a 1 decimal place, that will come out as 33.7 degrees. Now, what's really important about questions like this is to draw out a diagram like this one, because if it's something where there's a minus, it's a bit more complicated because you need to figure out the angle in a particular way. It's really, really useful in order to draw a diagram. You can find these values here, and we'll do some more complicated examples in a sec. So this brings us on to the final way that you can actually write a vector, which is in its magnitude direction form. Now, this is less commonly asked, but basically, if you have a vector and you have its magnitude and direction, without knowing anything else about the vector, this is actually enough in order for you to define the vector. So they could ask you to write it in this form. So here's an example of this where we need to write this vector in its magnitude direction form. And all this question is actually asking is just to find the magnitude and the direction of the vector. So as I said before, I think it's always really important to draw out a diagram, especially for the direction, because there's actually really no other way to solve it. You need a diagram for the direction. So that's what I'm going to do here. I'm just going to write out this vector on a very rough diagram. So it's minus 6, so it's going to be about here, and then it's 1, so we'll just say it's about here. So therefore we'll say that the vector is sort of like this, like that, where this is going to be 1 and this is going to be 6. I know it's minus 6, but because I've said it's going left, we don't need to put the minus. And we need to find the angle between the vector and the positive y-axis. So we actually need to find this angle here. This is very simple because remember that this is just going to be the exact same triangle here. This is going to be 1, and this is going to be 6, and this is still going to be a right angle triangle here. So this is the angle, so we can use SOHCAHTOA again. So the opposite is here. This is the hypotenuse, and this is the adjacent. Remember, we're using this triangle here now, like this. We know O and A, we know nothing about H, we're just going to ignore that. So therefore it's going to be tan theta. Obviously you actually find out it's always going to be tan theta for directions because we're always going to know O and A. Tan theta is equal to O over A. So sub in the values, tan theta is equal to O, which is 6 over 1 here, because that's A, which is just equal to 6, so tan theta is equal to 6. So therefore theta is going to be equal to the inverse tan of 6, which if you put into a calculator is equal to 80.5 degrees. So that's the direction. All we need to do now is find the magnitude, and that should be pretty easy. So for this vector, the magnitude, remember just to sub in these values here, is going to be equal to the square root of -6 squared plus 1 squared, which if you put into a calculator is equal to root 37. And therefore we figured it out in the magnitude direction form, with the magnitude equal to root 37 and the direction equal to 80.5 degrees. So I don't think that's too bad. The thing always with vectors is the direction, because you need to draw a diagram. The only thing I just need to stress is please draw out a diagram, because it's really, really important in order to figure out the direction. And if you do enough examples of it, it should hopefully be quite easy. So something you need to be aware of is something called a unit vector. A unit vector has a magnitude of 1, and that makes a unit vector unique. So a unit vector just has a magnitude of 1, and a very common exam question is for them to ask you to find a unit vector in the direction of another vector. So for example, let's say we have this vector here, which is A. They might ask you to find a unit vector in the direction of that. So what that's going to be is it's going to be a vector with a magnitude of 1, but it needs to be in the direction of A. In order to find that, so the unit vector in the direction of A is just equal to whatever A is, and then you just divide it by the magnitude of A. If you do that, that will give you the unit vector that will have a magnitude of 1. So here is a common exam question where they give you a vector and they want you to find the unit vector in the direction of that vector that they give you. So to draw a diagram, you don't really need a diagram for this question, but just to show you what's going on, if you draw quick axes, and the vector -5 plus 12j will look something like that. What they basically want you to do is to find this vector here with a magnitude of 1 in the direction of this vector, so it lies on that vector in the way. And the way you just do that is to find the magnitude of A. So the magnitude of A is equal to the square root of -5 squared plus 12 squared, which if you put it into a calculator is actually equal to 13. And therefore the unit vector is going to be equal to A over the magnitude of A, which is going to be equal to -5i plus 12j over 13, which is going to be equal to -5 over 13i plus 12 over 13j. And that is the unit vector in the direction of A. And if you want to, you can prove your answer by finding out that the magnitude of this is actually equal to 1, so therefore it is a unit vector. So you also need to know how to add and subtract two different vectors, and this is very, very easy. You just need to add or subtract the separate parts. So for example, let's say that we had two vectors, 2, 3, and we want to plus -1 and -4. What we basically do is we just do the separate parts, we add the separate parts. So the overall vector, if we add these two together, is just going to be 2 plus -1 on the top for the top part, and then the bottom part is just going to be 3 plus -4, and then this is just going to be 1, because remember plus and minus becomes a minus, and it's just going to be -1 on the bottom like this, and it's just going to be that. It's very simple. If it was in the I plus j form, so for example if it was something like -4i plus 6j, j, and let's say we were going to plus the vector plus 2i plus 2j, be the exact same thing, but we kind of treat I and j as if they were kind of like x and y, and we only do those specific parts. So it would be minus 4i plus 2i, which is equal to minus 2i, and it would be 6j plus 2j, which would be equal to 8j. Hopefully this is quite simple. Now, if we wanted to subtract two vectors, so let's say we were going to do 4, 3, and we were going to minus the vector 6, 1, then it's just the exact same thing. We just need to do it individually for the parts. So it's going to be equal to 4 minus 6 on the top, and then 3 minus 1 on the bottom. And then if you just do the maths, it will be minus 2 and then 2. So that's what this sum would equal to. Now, if it's in the I plus j form, it's the exact same thing. So, for example, let's say if we had I plus 2j, and we want to minus, let's say, 4i plus 5j. The important thing with this, remember, is to put brackets around the second vector, because remember, we want to minus the entire thing, not just the first term. So please remember to put brackets around it. It will be equal to, if we expand the brackets, it will be equal to I plus 2j, and then expand the brackets to minus 4i minus 5j. Please remember to do this bit at the end as well. And if we simplify this, again, we just do the individual terms. So it's going to be I minus 4i, which is going to be equal to minus 3i, and then 2j minus 5j, which is going to be equal to minus 3j. And that's the final answer. And then finally, they could ask you to multiply a vector by a number. So they could ask you to do something like 2 times 3, 1. There is actually a times here, but remember, for coefficients you don't need to put that. And all that means is that you just times everything in the vector by the number. So 2 times 3, 1 is just going to be equal to 2 times 3 and then 2 times 1, which, if you do the maths, is just equal to 6 and then 2 on the bottom. The exact same thing works with the I plus j, but please remember to put brackets. So for example, it could be minus 2 times, let's say, 4i minus 3j. That would just be equal to times everything by minus 2. So minus 2 times 4 is equal to minus 8i, and then minus 2 times minus 3 is equal to plus 6j. Overall, I don't think that's too bad. Just remember, it's just basic maths. So something you also need to know is how parallel vectors work. So let's say that we have a vector PQ, and if we say we have a vector PQ, what this means is we have a straight line vector that connects the points P and Q like this, and we put an arrow on the top to show that we are going from P to Q rather than in the opposite direction of from Q to P. There is a difference between those two things. We'll talk about that in a sec. And let's say that this is equal to A. If that means it's equal to A, it just means it's equal to some sort of vector. It doesn't really matter what it is. Let's just say something like 1, 2 or something like that. If we have another vector, let's say RS, so this is a vector that connects the points R and S in a straight line like this, so it's going to be RS again with the arrow on top to show that we're going from R to S. If PQ and RS are parallel, what this means is that RS is going to be equal to lambda A. Now, lambda is just some kind of Greek symbol. It just means some sort of number. But all it means is it's going to be some sort of number. So 2, 3, 4, something like that. And what this is saying is that RS is going to be a multiple of PQ. Lambda A is a multiple of A. So it could be 2, 3, etc. So it's going to be a multiple of this here. So for example, and it depends, lambda is dependent on the size of the vector. So let's say that RS is 2 times as big as PQ. That means that lambda is going to be equal to 2. So it's going to be 2A. So what that means is it's going to be 2 times this. 1, 2, which is obviously going to be equal to 2, 4. If it was 3 times as big, then that means that RS would be equal to 3A, which would then be equal to 3, 1, 2, which would then just be equal to 3, 6. That's very important for you to know is how parallel vectors work. And of course, if they were the same length, so let's pretend that we had two vectors like this, and they were the exact same length, then this means that they would actually be the same vector. It would actually, both of them, be A. This is something that comes up a lot and is very common, about the fact that you need to realize that if two parallel vectors are the same size, it means that they will have the same vectors. It's very common if they give you something like a rectangle, where you have two sides that are parallel on the same length, they will have the same vector A. So one key concept with vectors that's very important is that they're direction specific. So what this means is, let's say we have the vector PQ, and we have this arrow here to represent that we're going from P to Q. We have this arrow here as well to show that we're going from P to Q. And let's say that's equal to A, where A is just something like 1, 2, some sort of vector. Let's say that we want to know what the vector QP is. That means it's the exact same vector, but we're going from Q to P instead. So the arrow will be like this, and instead we write it as QP with the arrow like that. This will be the exact same vector, except for the fact that it will be minus A. That's the only difference. So let's say that, again, A is equal to 1, 2. That means that PQ will be equal to 1, 2. And that means that QP will just be equal to minus 1 times 1, 2. Remember, we don't really need to write the 1 here. It's just kind of implied, which will then be equal to minus 1. Minus 2. That is the only difference between the two, but that's the key thing with vectors. They're direction specific. It depends where you go from and where you go to. They will be different, and there will be different signs of each other. So this video has been a bit unstructured so far. I've just kind of thrown a load of information at you, because I think this is kind of what this topic is, in my opinion. So here's just a summary of everything I've talked about so far with vectors and everything you need to know. You've got column and I and J form, the magnitude, the unit vector in the direction of another vector, if they're parallel lines, how to add, subtract, and multiply vectors by a number, and then the fact that direction specific of it's the minus in the other direction. So one of the most fundamental concepts of vectors is to find vectors of unknown lines given the vectors of some other lines. So here's an example of this, where we have the triangle PQR, and we know that PQ is equal to A, and we know that QR is equal to B, and we need to find the vector PR here. Now, the way that we do this is that we go from P to R, like the vector is PR, but we go through other lines in order to do this. So we're going to start from P here, and we're going to go through this line here. Remember, we want to end up at R. So we're going to go through this line here, like this, and then in order to get from R to R, we're going to go through this line here. We go through this line in this direction, and we go in this line through this direction. So what it's going to be is PR is going to equal the lines that we've gone through. So it's PQ here, the first line that we went through, PQ plus QR, which is this line down here. And all this is then is, because these directions match and we know the values of them, it's just going to be equal to A plus B. And that's the final answer. PR is just equal to A plus B. This is a very fundamental concept with vectors in terms of how they work. So this is the exact same question, except this time RQ is equal to B. And I've done this just to exaggerate the point about vectors being direction specific. So it's the exact same question. We need to find PR, so we're going to go from P to R. So we're going to follow the line. So we start from P, and we're going to go down like this to Q in this direction. So PR is equal to PQ, and then we go like this in this direction. So it's going to be plus QR. But now B is not equal to QR, it's equal to RQ, because it's going in the opposite direction. And if you remember that if it's going in the opposite direction, QR is the exact same vector, it's just in opposite direction, so it's actually equal to minus RQ. So we can write this as is equal to PQ minus RQ, which is just equal to A minus B, as it's in the opposite direction. So just remember this about it being direction specific, and watch out for the arrows. Make sure you're going in the right direction. Really quick as well, I just want to do one quick tip that I've used sometimes in vectors that I've realised a long time of doing vectors. If you need to find something like P R, what I've found that the vectors that work is if, like this, the same in the middle, the letter is the same. So PQ plus QR. If the letters are the same, these kind of cancel out in a way in order to give PR. And that's kind of a way that you can know which vectors sum together in order to get PR. I found it useful in a select few circumstances, so I thought I'd put it here as well. So here's just a quick example. They talk a lot about parallelograms on the specs. This is just an example of this, where we're given a parallelogram, and we know that this side here is the vector A, and this side here is the vector B, and we need to find OC. So remember, OC connects O and C, so it's going to be this kind of diagonal straight line here that is actually drawn on the diagram, like that. So we need to find this vector here. Now the key to this is realizing that we have parallel lines that are the same size. So this line and this line are parallel, and they're both the same size, because that is one of the features of a parallelogram. So therefore this is also B, and the exact same logic is here, that this is also A. And then we can figure out the question. So we need to go from O to C. It doesn't actually matter which way we can go from, go this way or this way. I'm just going to go from the bottom. So we go from here to A, so OC is equal to OA, and then we go up like this, so it's plus AC. And we know both these lines because we are going in this direction constantly, so it's the same direction like this, so it's just the positives. So it's going to be equal to just A plus B. And that's the final answer. So please look out for these parallel lines that are the same size. This comes up quite a lot.